In IPv4, the class B address, actually we have class A, B, C, D, E, 5 addresses, that is the addressing scheme is divided like that. So this IPv4 is a 32-bit address, and when we write it as dotted decimal. That is the first 8-bit, then 8, then 8, then 8, and they are dotted, means separated by dot. So in class B address, the first 2 bits of the leftmost octet is a combination of 8-bit, is fixed to 10. Class B, the first 2 bit fixed as 10. So the first bit, if they are decided that it will be 10, this is fixed. So what all are remaining? The remaining of them, that is the next 14 bits. So 2 is 2 in 8. There are, if you deduct 8 minus 2, it will be 6. And the another octet, which is 8. 6 plus 8 is 14 bits. From here to here, these are the next 14 bits, and these are the network address. Please remember, there can be millions of network. So first we have to find the network, and then we have to find out the actual computer or a system inside that network, that is called the host. So these 14 bits are the network address in the class B address, and from here to here, these are the 16 bits. These are indicating the host address. So what is the range of IP address? When you fix 10 of an 8-bit address, so this is the first octet, leftmost octet. So 10 is fixed. What can be minimum? 00, 0000. This can be minimum. What can be maximum? All 10 you cannot change. So 11, 11, 11. And when you convert this into decimal, it will be 128, the minimum one, and the maximum will be 191. The others, after that, there are 3 octets more, so it will be 0.0, 0.0, 0.0, and then with number 91, it will be 0.255.255.255. So it is from 128 to 191. And since we have 14 bits for network address, how many networks can be formed using the class B address? It is 2 to the power 14. This is how it is computed, number of networks. And how many computer or system or tablet or the computing devices can be put in one network? It can be 2 to the power 16, and you know that the first and the last we cannot use. So it will be 2 to the power 16 minus 2. These are the host address it can be in class B address. The default subnet mask of class B, first of all, what is subnet mask? This subnet mask is used to separate the network address and the host address, because the 32-bit address is consisting of these two. So when you apply this default subnet mask, actually you AND it with the actual address being given. This 255 is basically 11111111. So when you AND this, you get the network address out of it from the IP address, right? So this default subnet mask, this is default, there can be many, but this is the default subnet mask of class B. So this class of IP address, where it is employed? It is employed for a medium network like the MNC companies, multinational companies. It is not very big, it is not very small, medium one. So we have an example here, 172.16.55.13. Now you tell me which address does it belong, which class? And this is very clear because we are discussing class B, so it is class B address. But how it is? See, the first octet, when it is from 128 to 191, this is the category of class B address. 172 is the first octet. Does it belong between 128 and 191? Yes, absolutely. That is why this is a class B address. Alright. So what are these octets or the numbers which represent the network? The first two. Remember, the default subnet mask is 255.255.x.x. So the 172.16. So this 10 is fixed. 14 bits are the network bits. So this 172.16 is the number, or you can say the representation for the network. So we AND it with 255.255.x.x, that is these two we get for the network. That is how subnet mask work with an IP to take out the network address. So 172.16 is the network it is representing. What is the remaining part? 55 and 13, that is .55 and .30. These are the remainder part which is actually representing a host. So first you have to find out the network, then the computing device inside that network, which is called the host. So 172.16.0.0, this is representing that this is a network. Okay. And then inside that we will have 172.16.1.1 that can be, or that can be given to the devices. So the device, let me just clear it to tell you that we have a number. Somebody comes up with a number of 172.16.254.3. Now, the devices with these two IP addresses, are they in the same network? Yes, you just have to check the first two octets. These first two octets, if there are 172.16, they are matching. You can easily say that these are on the same network. Let me write one more number, 172.55.54.74. Now you just have to match first two of it, 172 and 160. If they are not matching, that means the first one and the last one, which I've just written, they are not in the same network. All the three addresses are class B address. First two belong to one network, the third one belongs to another network. Okay, these two are in one network, the third one belongs to another network. All are class B address.